Hello dear students, today we'll start the new topic that is oscillation here. Discuss the translational motion. So translational motion is a one where the particle executes the motion in a straight line. This is also called as a motion of a particle in a straight line it is. So in a straight line. So one more motion is there, that is of projectile motion. So projectile motions. So we are going to study one by one detailing why we need to study here to understand the oscillation concept. So what is this oscillations? We need to understand the types of motion. In our universe, in our nature, we have a various types of motions are there where we are giving most preferences to the translational motion. For example, when vehicle is there, translational motion. When vehicle is moving on a straight road. So how we can say here, if you draw your own vehicle, right? So it has to travel on the straight road or else in the smooth surface here. So motion of a particle in a straight line it is. That we have already studied the biggest chapter, motion in a straight line. So that we know already here. And the second point is projectile motion. Projectile motion is a one when body executes the motion not on the straight line, but it makes an angle with a straight line path here. So once you throw the ball from the person who was standing one side and they were playing a game like catching the ball from one side to another side here. So this is nothing but the ball here. So the persons are standing here. If you want to make a path travel by the body, what you are going to do here, if you draw the tangent over the path traveled by the body, it will make an angle theta with a straight line here. So this is in the form of projectile motion, means it's making a projection with a straight path. Actually ball has to go in the same way here only, straight line. But it is not possible. It is throwing in the sense what it is making in an action so that it has to reach its own target but in a different path. That means it is not completely circle. That means it is not completely, or it is not showing the perfect straight line path only. That indicates here this is one of the motion executing by the bob or the ball here. It's showing the motion but not in a straight line, but in the form of making an angle which is said to be as a projectile motion. So these are the basic concept here. These are the very important motion of a particle when it is executing the motion on the path here. One is a translational motion and the one is a projectile motion. So as we move on towards the next path here, there are the different motions in a nature compared to these two. So one more motion is what here? We can say that a repetitive motion. So repetitive in the sense what it is? Uniform circular motion that we also studied in a previous chapter. So once again we will glance that type here, that is of repetitive motion, or else we can say that it is a uniform translational motion. The one more name for the uniform translation motion, it is a periodic motion it is. So periodic motion. So how to study this one periodic motion? So if we consider the earth here, right? Earth itself, what it is doing? It is a revolving around the sun here. So we have a 24 hours here per day. We are getting a 1 day and 1 night here. That indicates what here? For every 24 hours, the same process is going on here. So repetitive in a given or a fixed intervals of time it is. So for example, if you go ahead with a clock here, we have a 12 o'clock, 6 o'clock, right? 9 o'clock and 3 o'clock. So we are getting 12 o'clock twice the time in a day. So that is of 12 noon and 12 p.m. Right? Similarly, 3 o'clock and afternoon and the midnight. Similarly 6 o'clock, similarly 9 o'clock. Twice a day we are getting light. That means what here? Clock is revolving with the same circular path here with the fixed intervals of time here. With the fixed intervals of time. So once you go ahead with the earth as an example here, earth revolves around the sun, or else if you consider the different planets here, planets is also revolving around the earth here. If you go ahead with any of the planet in the solar system, all the planets are revolving around the sun, and earth is also revolving around the sun, and even though earth is also revolving on its own axis here, that means these are repeated after fixed intervals of the time here. Means it is going to be fixed intervals of time. You may say that at the 12 o'clock where will be the path of earth, at the 3 o'clock wall will be the path of the earth, 6 o'clock, 9 o'clock, but this process is repeating, it's not going to be ended. And the same way earth is also going to revolving around its own axis, that process is also going to be continuous. So also we can say that it is a uniform circular motion it is. So uniform circular motion it is. So that kind of a motion, when the particle executes the repetitive motions, or else we can also say that it is a repetitive it is, in a fixed intervals of time. So fixed intervals of time it is. So that kind of motion exhibiting by the particles, we can say that it is a periodic motion, and also we can say that a uniform circular motion here. Whereas the such motions are repeat themselves after certain intervals of time as a periodic motion here. This is one of the most important motion in a nature. So what are the motions we have discussed here? One is a translational motion. That means the motion of a particles in a straight line here, right? Then another one we have discussed, that is of projectile motion, where it is making an angle theta with the fixed path, right? And the third one we have discussed, that is of periodic motion it is. That is of periodic motion, where the particles executing circular motion, or else we can say that it is a uniform circular motion, or else also we can say that it is a repetitive motion on fixed intervals of time it is. Fixed intervals of time it is, right? So these the three periodic motions in a nature we have studied here. Next move on to that is a very important part of in the oscillation chapter is oscillatory motion. So what is that? Oscillatory motion. What does it mean, oscillatory motion? When body executing the periodic motion, we said that it is a repetitive. In such kind of a particles are there, they will behave like a periodic motions. Means they are going to be repeat in a fixed intervals of time, but different in their functions. They are different from the periodic table. They are not neither completely periodic motions executing by the particle, not the translationary, not the projectile motion. They are totally different from these all motions here. So such kind of motions are called as a oscillatory motion. That means once you consider the pendulum here, we have already simple pendulum experiment we have done. Those who did not done, you can just realize that once you take the wire and suspend the one bob here or any kind of a ball. So fixing in a sense what here, this is nothing but the rigid body where it is going to be fixed, right? So once bob is a fixed, I may say this is a fixed point. Stretch this bob for the certain distance here and it will reach to the one point. I can say this is the point. this point I can say that it is an extreme position. Extreme in the sense what here? It's going to reach to the one point here, and it is not fixed there only. It'll try to come to its a mean position. Mean position in the sense what here? Fixed position here. And after reaching this point, again it will not be fixed at this point. So it will move towards the another one extreme position. Means there are the two extreme positions are there here. At what actually in the, if the bob is executing the periodic motion, means it has to move in this direction, continuously repeat. But this process is not taking place by the bob here. What the process is taking place is here. So it is nothing but the one journey and second journey. And next what it will do, it will go ahead with here. Means before reaching to this point, it reached to this here. Again it will come, again it will. So this process is continuous, but it is not a periodic. So it is a different from the periodic motion. That means what here? To and fro motion. To and fro motion about a fixed point. So this is the about a fixed point is called as a oscillatory motion or the vibratory motion here. So there are the oscillatory motion when the particle execute the motion which is repetitive in nature. So which act as a which is a repetitive in nature, but different from periodic motion. Different from periodic motion here. So different from periodic motion. So how we can say that? So comparing this oscillatory motion and the periodic motions, first we have to understand what is periodic motion. So periodic motion we have already discussed 2 minutes back. That means those are the particles which executing the repetitive motion in a fixed intervals of time. There are some particles like pendulum maybe, or the boy is swinging in swing there, right? And you can able to see the boat while traveling in the water river there. So it will go up and come down, up and down. That means what here? It's taking a path here and coming down, taking a path, coming down, moving up, down, up, down. So that means it's not going to complete the complete circular path. It's not going to be shows that repetition is takes place in the same circular path. It's not a circular path, but it is not showing that it is not repeating. It is repeating. It's said to be as a repetitive in motion, but it is not saying that it is a periodic motion. What periodic motions tells here? Completely circular form, and it has to be going to be fixed rotation there. Rotation in the sense what? It has to be in a uniform circular motion, fixed intervals of time it is. But in oscillatory motion, where the particles executes behaves like a repetitive in nature, it's going to be repetitive. You can say that bob is moving in this direction and coming this direction, here, 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 here. This process is repeating, right? This process is repeating. It acts like a repetitive motion, but it is not exactly the repetitive motion it is. Why? Means this journey we can say that it is a two motion, and this journey we can say that it is a true or a fro motion it is. To and fro motion of a particle of a periodic motion about a fixed point. So here I can say that it is a fixed intervals of time it is. Here it is totally depend upon the fixed point. This is of the fixed point here. So to and fro motion of a particles about a fixed point, right? So such kind of a body executing the motions, we can say that it is a oscillatory motion. So to understand this oscillatory motion, we'll go ahead with a very important and very easy manner of understanding the oscillation motion. Consider the insect here. So what is that? Insect. Or else we can say that periodic motion and oscillatory motions, the differences once you understand, no, it is a very easy to understand oscillatory motion. I said in our nature many motions are there, that is of translational motion, projectile motion, periodic motion, and next comes here oscillatory motion. So just now we have already discussed, but the thing is that we want more clarification how we can say that it is not a periodic motion. So once you go ahead with the bob here, or else we can say pendulum bob, rigid body here. So attach this bob. I can say this is a fixed point. Why I am going to say here fixed point? So unless you disturb this position, bob will not move towards the next position here. If you just stretch it here, it will move towards the one extreme position. I can say this is a bob is going to set. Maybe it is for a 2 second it is, or a 1 second, right? And it will not come back. I mean, it will not going to be stay there only. It will try to move towards the main position where it has started the journey here. And after coming back to this position, and here also it is not going to be fixed. And means, as in case of a string here, what are you doing? It's showing the elastic power here, right? So once you stretch it here, it'll try to come back to its original position. That doesn't mean that it's go here and it will fixed here. It will try to do the up, down, up, down, up, down, until its energy is going to be lost here. So when energy is lost by doing this process, at that time once again it will come back to its original position where it is started the journey. Similarly, here also once you consider the bob here, right, it's moving towards the one extreme position and it is coming towards the mean position first. Energy is not completely lost, it has the energy. Again it will move towards the another extreme position here. That means it's going to be repeat this process until it has its own energy there. Once energy is going to be lost, it's going to be coming, moving, coming, moving, coming, moving. So first, second extreme, first extreme position, second extreme position. So it will comes and fixed at the energy lost position. At this point, I'm going to say that it is a force is equal to 0. That means net force is equal to 0 here. When net force is 0, acceleration is also 0. So once one more concept comes here, force. How the force is there here? There is a one force which is acting on a particle to reach towards the mean position. So that force I can say that it is a F is equal to minus k raised to n of, minus k, I'll repeat once again, minus k into x raised to n. You can take instead of x, y also. I'll explain the each term how it comes here. Once bob is moving from the mean position, or else we can say that it is a fixed position towards the one extreme position here. Can I say this is a displacement experienced by the particle from the mean position? From the mean position. Recall here mathematical scale. Middle point will be the 0 here. Right part will be the positive, right? So I can say that it is a plus 1, plus 2, plus 3, plus 4, so on. And recall the negative part is a minus 1, minus 2, minus 3, minus 4 here, right? Right. So this is a mathematical scale here. So when bob is moving from a mean position, means a fixed position, to the one extreme position here, in this case, same case I'm explaining here. So concentrate. And this part is moving on the positive side of your meter scale, assuming that right side it is moving. That means displacement taken place by the body or a particle from mean position to the one extreme position, that is of positive here. Displacement is a positive here, right? So once the positive is there here, body is moving and it is not standing here only. There is a force which is acting on the particles. It's try to move towards the mean position. It is not fixing here only. If it would have fixed here, we can say that body is reached to the one point. That's it. And that will be the explanation of one more concept. It will not explain the oscillatory motion. It is not doing like that. Bob is going to be going to the first extreme position and fraction of a second it will come back to its original position. Original in the sense where it is started the journey to take a displacement. So I can say this point as a mean position here. Mean position also we can say that it is an equilibrium position. So those who have understood the exactly equilibrium position, we can say that it is a stable equilibrium position. Stable equilibrium position. Yes, that means what here? Body is going to be balanced at this centralized portion of a thing here. Here, body is a fixed. Fixed in a sense means it is going to be balanced in both the sides. Once it is stretched here, it's going to be one extreme position. And it will not stand there only, it will come towards the main position. The force which is acting on this particle, it's trying to, not only try, it makes the body to reach towards the mean position. That means force is acting on the body here. What kind of a force it is? That is nothing but the oscillatory force only. It's not going to be fixed there only. It makes that such a force which is acting on a particles to move towards the mean position. Means it is there in this direction. When force is there, acceleration is along the direction of force it is. So acceleration is also moving towards the mean position here. Right? So force is moving in this direction. That means towards the mean position here. So here, if you put y in the sense what here? Nothing but the acceleration. So you should not get confused. That's why I'm taking x here. Because it is along the x direction. It is. So this is the suspension is a y direction. Right? So it is x is a positive here. Then we can say if you go ahead with the n, what is this n power here? N power is number of odd numbers it is. I'll explain. If you go ahead with the n is equal to 0, put n is equal to 0. So what will be the force which is acting on the particle here? Let us go ahead. F is equal to minus k x raised to 0. That means what? F is equal to 0. 0 in the sense what here? At the mean position, F is equal to 0 here. That means for the stable equilibrium part of the body or particles, force is exactly 0. It is means force is not acting on it. When force will acting on it? When it reach to the extreme position. So here I can say x raised to n. Here n will be, I can take 1. 1 is an odd number. And you can take a 3 also. You can take a 5 also. You can take a 7 also. Why odd means it is moving one side and second time it is moving to the next extreme position. Third time it is coming. Means 1, 3, 5, 7. So how we can cross check here? It will comes odd only. 1, 2, 3, 4, 5, 6, 7. Have you identified? Here in this position is odd. Odd in the sense what here? First it will start. For the second part it will reach to this point. Third part again it is coming. Means first, third, 5, 7. So like that odd numbers will going to take place. Similarly here also. 2, 4, 6, 8. That indicates what here? 1 second or a 1 displacement is going to be skipped with the another extreme position here. Moving to the another part. So generally we can say it as a odd it is. For this will be the odd. For this will be the odd. So totally odd oscillations. Or I mean odd number is going to be preferable here. How the force is acting on the same particle where it is executing the motion here and trying, and it moves towards those particles is a stable point it is, or else a mean position fixed point it is, where its a force is going to be 0. 0 it means it's totally 0 it is, nil it is. At this mean position, force is going to be negligible here. So let us go ahead with the considering the n is equal to 1 here. So what we are getting here, F is equal to minus of k raised to 1. So look at here, F is equal to minus k. Why minus k here? If the displacement is in the positive direction, so force will be negative it is. Force will be negative. How we can say that a force will be negative means always a force is opposite to the direction of displacement. So body is trying to move in this direction, moving from mean position to the one extreme position. It's moving in this direction, but the force which is acting on the body is moving towards the mean position. So I can say that force which is acting on the body is opposite to the displacement. Opposite to the displacement. So one more concept comes here, opposite to the displacement. So this is the displacement moving from x. X in the sense what here? Mean position. So from here it is moving. I'll read out once again, so you may get confusion with the explaining part here. One extreme position, another extreme position here. So it is taking the displacement x. First I am explaining for the x positive displacement. So this is the displacement. Once you go ahead with the body is executing the displacement on the straight line here, we can say x is equal to 0 here, where initial energy is equal to 0, right? So when it reaches to this point, we'll have final velocity v here. That means final velocity. So this part what we say, distance traveled from initial point to the final point. Similarly, body is taking the displacement here from the mean position. So mean position in the sense what it is, fixed point or a equilibrium state. So if such a displacement is taking place, the force which is acting in the body is reaches towards the mean position. Means displacement is there in this direction, force is there in this direction. That means opposite to the direction of displacement here. So that's why F will be negative in case the displacement is positive here. Come to this part, means for the second extreme position here. So for your number scale, for the left side it is a negative here, right? So displacement is a measured from the mean position here. I can say x is equal to negative here. Say n is equal to minus 2. So n is equal to minus 2 here. So again the force which is acting on the particle, here also particle is not going to be fixed. It's moving towards the mean position where it is a stable point or a stable equilibrium position it is. For this position we are going to say it is a mean position also. Mean means what here? Stable one it is, fixed one it is. So here again the force is moving towards the mean position. Where force is there, definitely acceleration will also be there along the direction of force. Here also along the direction of force. So acceleration is also moving towards the mean position. Here also moving towards the mean position here. So this is the process from here to here, here to here. So one more concept will comes here, how it is reaching from here to here, here to here, right? So once we have understood one path of the journey of the particle here, it is easy to understand the another path of the journey, how it is taking place, right? So force is there which is acting on the particles moving towards the mean position here. It is always opposite to the direction of displacement here. Here n is equal to how much we have taken? Minus 2. So what is the force which is acting on the particle here? Minus k of x raised to minus 2. So minus and minus will becomes positive here. So force which is acting on it is plus kx square here. That means what? F will be positive when displacement will be negative here. This is only this part of the journey, right? So once it is moving here, again force is moving towards this direction. Force is there, acceleration is also towards the mean position. Here again moving towards the mean position, again it is moving to the next extreme position. Force is there, moving towards the mean position, and acceleration, displacement is this side. So this process is going to be continuous until, except some cases, except energy is lost here. Until energy is lost, it's going to be process is repetitive. So from here to here, here to here, here to here, here to here, but it is not uniform motion. It is of two motion and fro motion, totally different from the periodic motion, right? So all oscillatory motion of a particle is not said to be as a periodic motion, but all periodic motion is not to be set as a oscillatory motion. So you have to understand this concept clearly here. Periodic motion means what? All the particles, yeah, it is exhibiting the uniform circular motion. In that, many may be which act as an oscillatory motion. Means it is not completely oscillation, uniform motion. It's exhibiting the to and fro motion. So that's why we are saying all periodic motions are not a oscillatory, but all oscillatory motions are said to be as a periodic motions. Whichever the oscillatory motion which is exhibiting the by the particle here, it may be to and fro motion, it may be a circular motion, so it may be any kind of it. So that will be the part of periodic motion. So that's why we are saying oscillatory motion executing by the particle, it behaves repetitive in nature but different from the periodic motion. Means different from the periodic motions, means it will completely takes place the to and fro motion, not the uniform motion here. So let us concentrate with the example here, insect. So once insect is there, it's going to be climbing up and falling down. So let us make a graph here, height versus time here. So I can take a 1 second, 2 second, 3 second, so on here, right? So height will be, I'm not going to measure any kind of a reading here. For 1 second it reaches to this point, insect, it's climbing up at us. This height may be of the plant, so it is moving on the plant here. For 1 second it reaches to this point, height here. For the 2 second it reaches to this point. You can make a graph it here. For the 2 seconds this part, for the 3 seconds it may climbs up here. For the 4 second it climbs this point, so it's going to be climbing. So if you go ahead with the drawing the graph here, this is a climbing up of the plant here by the insect. So it is falling down, it is going to be fall down now. For the same 4 seconds it reaches to this point, so this point will be act as a mean position here, right? Because once it reached here, again it's starting falling here. Means for the 3 seconds it reached to this height, for the 2 seconds it reached to this height, for the 1 second it reached to this height. So this will be the again 4 second, 3 second and 2 seconds. Draw this graph. This is what here? To motion. This is what? Fro motion. And this is going to be continuously repeat this. So this is the repetitive to and fro motion by the insect while climbing the plant and falling down here. By the same insect is taking the climbing of the plant, experiences the one kind of a motion here. When it reaches to the mean position, it starts falling. For the first 4 seconds, falling means it is very fast. So next 3 seconds it reaches to this point, 2 seconds this point, 1 second this point, and the time t is equal to 0. It reaches to this point. Again it will start climbing, again falling, climbing, falling. So this is called as a repetitive motion, but not the periodic motion. Not the periodic motion. So this is of a oscillatory motion here. So this is the difference between the periodic motion of a particles exhibiting the motion here, and the same particles exhibiting the to and fro motion, we can say that it is a oscillatory motion. That's why we are saying all particles, when it is experiences the oscillatory motion, is not the periodic motion, not the periodic motion. So concentrate, all oscillatory motions are set experiences the repetitive motion, but not the periodic motion. It's a one of the part of the periodic motion here. But all periodic motions means earth will not be considered as a oscillatory motion. Earth will be considered as a completely periodic motion, means it is a repeating, or we can say that it is a uniform circular motion. So all oscillatory motions which experienced by the particles is a what here, part of a periodic motion here, but not all the periodic motions experienced by the particles as said to be as a oscillatory motion here. Right? So now let us move on to the one same concept, that is we are going to understand. This is a half portion, no? How it is completed. Height, we can write it here with a motion of a straight line, as we in case of S is equal to ut plus half at square, no? Here A will be equal to G. G means it is climbing down, no? Acceleration due to gravity. So I can write it here, H is equal to, H will be the distance, right? So initially plus half gt square. So this is the displacement experienced by the insect while climbing the plant and falling down here.